Hello YouTube, thought we'd do a quick video here. I'm going to be doing some voltage injection. Let me kind of explain the setup here. If you have not been following my videos, I have the Retevis RT97 GMRS 2A radio repeater on the workbench. Obviously I have it out of the case, so that's what you're seeing here. Right here is the setup of it. And I did put the repeater on low power using the software before I took it apart. And I do have a clamp-on heatsink because the output IC that does the transmission does get warm. So I did put a clamp-on heatsink. And again, the repeater is on low power. I turn it down. I also have a voltmeter here, you can see. And then I also have the digital microscope on the circuit board of the repeater, as you can tell. Now, I also have a handheld that's tuned to the repeater frequency. This is my receive radio. And I have another handheld that will be transmitting to key up the repeater. And it will be like this. Okay, as you can tell here, you'll see the receive radio. The green light will come on. And you hear the squelch break when the repeater's keyed up. Okay, so now what I'm doing is I'm trying to modify this repeater so I can add a DB9 connector or a data port so I can hook it up to a computer or an interface box or whatever. When I bought this, I did not realize at the time Retevis does sell a model that has the DB9 connector already on it, and that is the model RT97S. Okay, mine is the RT97 without the S. So I did not know this until months later, which by then it was too late. I also have, and just to point out too before I forget, this repeater is hooked up to a dummy load and to a duplexer that's off camera. You can kind of see the duplexer here a little bit, but it is hooked up to a dummy load, just to let you know that too. So what we're going to do is, to do this DB9 connector, I need certain areas or certain pins to make the DB9 connector work. And I believe I found all the pins. I'm not for sure, but I need to find the transmit pin. And what I mean by that is I need to find where on this circuit board can I hook up a wire and have it be the transmit wire, so that when I hook it up to the computer, I can use that to turn on the repeater when it needs to transmit. Now, a couple of things here is I kind of have an idea what part of the circuit is the transmit circuit, so I know where to kind of start. Also, too, what you're going to need is a voltmeter and a adjustable power supply to do voltage injection. This is good for low voltage, low current circuits. If you want to try to turn a circuit on, this is one way of doing it with a voltage. Now, what I'm going to do is I'm going to take my meter probe here and I'm going to go to a spot on the circuit board that I think is the transmission or the TX part of the circuit. And I'm going ahead and put my meter probe on there now. And I don't see any voltages, which is good because I don't want a voltage there. I want a transmit circuit. So when I key up this radio, if I'm in the transmit part of the circuit, I should see a voltage. And I do, 3.1. Only when the radio's keyed up. You can see on this radio here, you can see it it goes into receive mode because the repeater's keying up. Let's do it one more time. 3.1 volts. So now, if I take the power supply that's off camera, you can't see it, and I adjust it to 3 volts, which is close enough. I know we measured 3.1, but 3 volts is close enough. If I adjust the power supply to 3 volts to match what I measured, I can see if I key up the repeater. So this probe here is hooked up to the power supply. So if I take my meter probe and touch it on here, you can see it's 3 volts. Okay? let's see if I can key up the repeater by touching 3 volts on that spot. Now, for demonstration purposes, just to show you there's 3 volts there, I'm going to put a jumper wire on my meter probe, and I'm going to put a jumper wire on my voltage probe. And you will see, on the meter here, you will see there is a voltage there. Okay? Now, if I touch this spot, repeater's not keying up. There is a voltage drop, so I know that I am touching the spot, but the repeater is not keying up, so that tells me this is not the spot I want. I'm applying a voltage of 3 volts. You can see the meter voltage drop, so that tells me I'm making a connection. And if I take it off, it goes back up. Repeater did not key up because I don't see it in the radio, and I don't hear the squelch tail breaking through the receive radio. So this is what voltage injection is. You can use it to try to trick a circuit to see if it turns on. But again, it's very important that you check the voltage first with a meter, obviously, because you need to know what to adjust your power supply to match that same voltage. Okay? So it's very important that you do that. But this can be applied to other circuits. It doesn't necessarily mean it has to be a circuit for a repeater. You can apply this to any other circuits as long as you test the voltage so you know what to adjust your power supply to, and then you can go ahead and apply that voltage to the circuit to see if it turns on. Now, the thing is, with this repeater, I do not know if I can do this. This repeater is also controlled by a microprocessor, and that microprocessor sends data. It talks to the 1846 chip. It talks to it. So if that's the case where I cannot turn on the chip because I need data, I need to talk, then I will not be able to do it this simple way of applying a voltage to turn the repeater on. Now, if that's the case, I don't think I'm going to go elaborate and build a circuit for that. But hopefully that's not the case. But by doing this, I'm hoping to find the transmit pin that I need to activate the repeater, so I can hook it up to a computer or DB9 connector. So, at any rate, that's what voltage injection is, or how it's used in this particular case. If you have any questions or comments, please post them down below. Please subscribe. Thank you, and have a good day.